Finally, we get to synthesis. So when planning a synthesis involving electrophilic aromatic substitution, a couple of things need to be kept in mind. Number one, careful attention must be paid to the order in which the reactions are carried out. This is the most important point. The order. The order. What does that mean? So if we look at this reaction and we're supposed to synthesize it from benzene, we know we have an alkyl group here, tert-butyl. We know we have a nitro. Right away, we can think of those reactions, nitration and Friedel-Crafts. And then we just say, okay, let's just throw everything in there. It doesn't matter what order. That would be the biggest mistake you would be making, because not only you lost points for not putting them in the right order, but the reaction may not take place if you put them in the wrong order. So that's why it says, that's why this is the number one rule, is you have to be very careful, okay, to the order in which the reactions are carried out. So very well, let's look at this reaction. We have an alkyl group here, a tert-butyl, and we have a nitro group. So we can think of the reactions right away. How would you add a group such as this? Tert-butyl. The only thing you can think of it is by Friedel-Crafts alkylation. You can go back and check that Friedel-Crafts was the way to add an alkyl group. This is an alkyl group. Second is, how do we add this? Well, that's a nitration reaction. Very well. They have to be in these positions. So you cannot substitute this for orthonitro or metanitro. Doesn't work that way. Plus, you have to know that the directing effect of these substituents. We know the nitro is meta-directing, and we know the tert-butyl is orthopara, but the para tends to be favored because this is a large, bulky group. So you see how I'm organizing my information. Very good. So we start with benzene. And we say, okay, I can do the Friedel-Crafts alkylation. And when I do that, I will get the group right there, which is, by the way, this. This is the same as that. Very good. Now, since I was able to add one of the substituents, I need the next reaction. And the next reaction is the nitration reaction. So this is reaction 1. This is reaction 2. And watch why this order makes sense. Okay. Number one is that, as we said, this is a bulky group. So it's going to direct to the para. So that means here. And plus, this is an activating group. So it's going to make the reaction go faster. And then we can add NO2 right there, and we would be done. So that's the idea here. Now, so this is how you would do it. This is the ideal way, the correct way. The incorrect way, and let me say I'm a student here. By the way, make sure you have excess amount of this, a large excess, because remember, we can have too much we can have the tri-substituted, the di-substituted, etc. So go back to where we talked about di-substitutions of the Friedel-Crafts can happen. The incorrect way would be the following. Would be say, okay, let me add the nitro. And for some reason, sometimes students love to start with the nitration. Some, I said not everybody. It's okay, it's a process of learning. And then they would do the following. They would say, okay, now when we go to the next step and say, okay, let's add the Friedel-Crafts. Let's go add the alkyl group, the tert-butyl. We encounter two problems here, two dilemmas. Number one is that the nitro is meta-directing. So meaning that it will add right there or right there, not where we need it to be, especially where you started right there. So you see the first problem? The second problem is we learned about this, and let me refer back to this. Let me go back a few pages. So over here, we said deactivated meta-directing benzene derivatives and aniline derivatives give poor yields of Friedel-Crafts products and should not be used in the reaction. So watch here, you see you have the nitro right there, the nitro group. So this is going to give you a very, very poor yield of the Friedel-Crafts alkylation. So in this case, there's going to be no reaction for two reasons. I'll write them here. NO2 is meta-directing. And for two is that the meta group, it's a deactivated benzene ring. No Friedel-Crafts alkylation. So absorb this, think about what I just said in here, and you can skip my video for the next, or you can watch a video where I'm discussing the next one, or you can really attempt it on your own and read what it says here. So try this on your own before you watch the next video. It will definitely help if you can think about it before you see the solution.